Hello, this video is an introduction on how to handle your data with MDAnalysis. I will show you how to load your topologies and trajectories and will explain the basics of work with Universe and AtomGroup classes. Any MDAnalysis script starts with creating the universe object, which contains your topological information and your trajectory information. MDAnalysis library does not make a clear distinction between topological files and trajectory files. It depends entirely on the file format. For example, some file formats like PDB can be both. PDB file can contain both definitions of your atoms and multiple models representing different frames of your trajectory. Such formats as GRO and TPR, they are topological files. They contain only definitions of your system, plus TPR file also contains parameters of your molecular dynamic simulation. As for TRR and XTC files, they are trajectory file formats, and they contain only trajectory information like time point, coordinates of atoms at a specific frame of the trajectory, sometimes velocities and forces, and trajectory files are meant to be used with topological files which provide definition for particles. Because of this diversity, there are multiple ways to create a universe. For example, you can pass a single file as topological parameters, you can pass topological file and trajectory file, you can pass topological file and multiple trajectory files as a list or one by one. You can also create empty universe object and create something inside of this object. After universe comes AtomGroup. Universe itself contains AtomGroup and you can access it as field atoms. AtomGroup, you can imagine it as a set of your atoms in your system, and you can perform different manipulations with your AtomGroup. For example, you can select specific atoms using MDAnalysis selection language. You can merge together two such sets. You can find the intersections of two such sets, and etc. This is often useful, and we will cover in this video one of the ways to use this versatility to get some result. So first I'm going to show you as an example in real life topological file GRO and trajectory file XTC, and I will use PyMol for this demonstration. Although there is a number of ways you can actually visualize your topologies and trajectories in Jupyter Notebook using NGL view, for example. I will later cover it separately. So as you can see, we have here dimer of two protein subunits, two protein chains with two ligands in conservative sites of these two subunits, and I have already centered it, removed water and ions, and I have aligned all the frames of trajectory to get a smooth video on conformational changes. As with VMD, you first load your file with definitions of your atoms, which is a topological file, and then you load corresponding trajectory. PyMol will connect these two files by itself. Previous videos I used sample topological and trajectory files, and now I am going to show you how to actually load your data to analyze it with MDAnalysis, and it is relatively straightforward. You define as the first argument of universe constructor the path to your topological file as a string, and then the same way you define the path to your trajectory. With dot and slash I specify relative paths to my files, which are located in the same folder as my Jupyter Notebook. I will now run the same script that I used in my previous video to introduce you to RMSD calculations with MDAnalysis, and we will see the RMSD curve plotted with Matplotlib. And here it is. So essentially there is nothing difficult, all the hard stuff is happening under the hood, and you only need to write a high level code to actually get the desired result. And the greatest thing with such libs is that you can easily repurpose your old code and use it in a different way with minimal changes. Now I will show you how to work with atom groups, and specifically how to select atoms from your universe and write them in a separate files. Universe class has associated method select atoms, and you pass a string with your selection written in MDAnalysis selection language, which I will cover later, but for now you only need to know some basic keywords like res name to understand what is going on, and it is really similar to selection languages used by other packages. These three variables, HTF and protein, are the atom groups. Each atom group has a method write, and there you can specify as an argument relative path to where you want to write your information, and it will also deduce format based on the extension in your string. So basically, although MDAnalysis library is primarily for analysis of molecular dynamics trajectories, you can also use it to work with your topological files alone. Like PDB file, you can use it to write a script which, for example, takes some complex and separates it into the components, or on the contrary, combine multiple such topological files like PDB into one complex, which is especially useful during the preparation stage of your simulation. These GRO files are perfectly valid and can be visualized in PyMol. PyMol treats them all like separate entries. Finally, let's combine them back into one complex and see if MDAnalysis will notice the difference with our original topological file. To do this, we first load all our three files into separate universes, and then we use the method merge of MDAnalysis library and pass atom groups of these universes as its arguments, which will combine them into one merged universe complex. This is just a harmless warning. MDAnalysis complains that we have not defined our unit cell dimensions. Now we will just use our newly merged complex instead of the original one, as a definition for atoms in our trajectory and see if it will in any way impact the RMSD calculations, which it won't. So yes, here we go, and that's all for today. If you have any questions or feedback, you can write them in the comment section.